Hey kids, it's Mark Miller here. Rory's with me.
I'm here too.
How you doing,
Hello,
buddy?
everybody. I'm doing good, my friend. How are you?
Pretty good. Fred's here.
Fred's here. Well, we're good then, aren't we?
We're good to go. Let's do it. I had power outage for about an hour this morning. We'll get out of this and write some code. So we're let's see where we left off. I haven't worked on this in almost a week. So it was last Thursday when we last worked on this.
Okay.
Let's get the Brio camera on here, right here. This is that's that view right there. Let's get to my Specialplex buttons and get in here and hit the fireball button. Does anything happen? Nothing. Nothing. Wait, I know why it's not. I think because I have a checkbox that enables it that I forgot about. Because, you know, it's been about a week. All right, one more time. Button now. Fireball now. There we go.
There we are.
All right, so check this out. Behind my hand.
Yeah.
In front of my hand.
Oh, nice.
It's kind of cool. It's a little bit cool. What I did is I decided I'm gonna put it about a little bit in front of, I'm gonna put it in 3D space. I'm gonna take a normal to my hand and stick it out about that far. So it's about a 1 palm's width. And also depending on where my hand is facing, it decides whether to put it on the front plane or the back plane, is what it's doing here. So hold on, let's come in here, get in the fireball. So there's on the front plane, and now it's on the back plane, right there. So I can just kind
of nice.
Flip it around a little bit. And if I want to bring it across over here, I can do, but notice, see what's happening? Illusion dispelled right here.
A little bit.
Right? But if I do this, as I bring it across the front, see what I'm saying? I do that kind of a thing right there. So that's kind of a way to do it. Let's move this. There we go, just a little
So you can kind of imagine a sort of a U shape that surrounds the front of your head, which is the valid places to be.
Yeah. If I'm moving quickly, it's not too bad. So the other thing we worked on, holy cow, it took us a while to kind of get to this point, is getting it to detect throws. We got to a point where it was kind of doing it, and then we lost the feedback because I also wanted to support moving backwards and forwards. So I think maybe we get the feedback back so we can see when the throw occurs. I think we might do that. Fright LOL says, today I borrowed from the library Headfirst Learn to Code. Headfirst books series are awesome.
I do like those.
A Learner's Guide to Coding and Computational Thinking by Eric Freeman. Python. I am
one of the nice things about them is they've got quite a graphical way of showing things. So or multiple ways, in fact, of showing things. So you get the basic description, but you also get some image or some person with, if you've got a queue, you can have the items in the queue diagrammatically shown. So it's nice to get those multiple different ways of expressing a concept.
Yep, no, I'm a huge fan of the series. They're awesome. Okay. So I want to get the feedback back. Yasmin and Deuces out there says the Headfirst books really are awesome. Can't wait for the new C# 4th edition coming out this December. I might have to get that. I just might have to do that too. I'm a big fan of those books. All right, so here's the deal. Dragonfront game is where this used to reside. The code for drawing the fireballs and the hand following effects. That's now moved to the Ancestor class Dragon Game. But what didn't move also is the ability to float text. So let's go look at my float text. I don't know, something called float out here. Let's do this. Ooh, high text floater. That might be good. Oh, that's what Dragonfront game is. It's got this method called add floating text, which looks like this, which calls add text in its text animations. Text animations looks like this. I think what I'm going to do is I'm going to move this to Dragon Game, since we now want them in both places no matter what.
So what's your motivation for wanting floating text
I want to be able
in the background? Because surely that means it inherently gets obscured by things.
Right, I just want to be able to use some simple code to show where the throw is and show where it is on screen. So I want to say throwing, even if it's obscured a little bit.
Mm-hmm.
I don't know, your question now makes me rethink this whole move in this direction.
Well, your answer is kind of that it's more for diagnostic purposes.
Right.
But it won't be there sort of when Dragon Compass is running or what have you.
Yeah, what other choices do I have?
That's quite legit. That's just, yeah. I was thinking from an end user perspective more than I am diagnostic, which obviously does play into what we need.
Yeah, I don't know. I think I'm gonna continue on along this path, because I don't think the harm of coming along this path is great. I don't think it's too bad. So okay, so there's add floating text. I'm gonna take add floating text and get it out of here as well. Put it down over here. Why not? I'll throw it right down here. So there only this in here is on text animations, which we just moved. Okay. We need these as well. Now, update screen. I want to take these and put this into update positions. Why aren't we drawing them is my question. Oh, here we are drawing them. Update screen. Oh, I see. We kind of do this calculation here, and then down here we render them. I think it's probably going to be pretty harmless to do this, like that. Then what I want to do is I think I'll extract all these to a method here that's going to be called render text animations, like that. And then we're going to take that and we're going to move it out to Dragon Game, like this. And I think we're going to make it protected, like that. And then so we're getting rid of anything that's expired, and we're updating positions and calling render on that. I want to swap the order of these parameters. Like that. So there's render text animations in update screen and Dragon front game. In Dragon back game, we need to do the same thing. Let's go find that. Probably faster to use Code Rush. DBG for Dragon back game. There it is. And we want to make that call from our render, whatever our render method is inside of here. Saw one with yellow on it, right? Update screen before world render. Maybe I'm looking for update screen. Update screen.
So what's the meaning, Mark, there on the UI? The Dragon back game has been lit up in a couple of cases.
Yeah, it's lit up because it's the same file I'm in. It's just a feature request I had.
Oh, this is the one you had a little while back, yeah.
Yeah.
Because that's quite noticeable. That's pretty good.
It's not bad. Okay, update screen, and then we'll do that with the render text animation. Like that. So I think with that now we can go back to Dragon Game and look. Hopefully there's going to be add floating text call in here that I commented out because I moved it up here. There it is, right there. Okay. That's what I want. Okay, so that's the change. Let's go to the overlays, refresh them both. There's the front overlay refreshed. There's the back overlay refreshed. There's the refresh of the data. And now we should be able to see the throwing when it occurs here. So assuming this is all still working, so it's active there. Going to the buttons on the Stream Deck. And let's hit the fireball button. Nothing. It's coming up. We lost signal R. Does that make sense? No, we're still getting connection here. Let's turn that off and toggle that back. Oh wait, something is not finished refreshing. Looks like the front page still has scroll bars on it. There we go. Let's see if that's any better. There we go. All right, so now we want to look for a throw. So I'm expecting like a little toss to trigger it. And I'm not seeing anything.
No.
Guess we have to go back and look at the code for throwing. Oh, wait. I think, hold on. Toss, throwing up. We only get one toss. Because I wrote code to set a flag that said, okay, we're tossing now, so you don't have it in your hand anymore.
Right.
I think we're kind of okay. All right. So now what I want to do is I want to go into my D&D app right up here, and we want to figure out what's going on when we do the throw. We want to go to hand 2D, as I'm recalling. Throwing speed. Got some cool booleans here. Is fist, is flat. We did those as well, I think, on, I want to say Thursday. Were you not with us on Thursday, Rory?
I thought I was, but perhaps not for the whole of it. Actually,
Maybe.
Of course, I would have been a little earlier.
Yeah, maybe after.
Before the end of the stream.
Anyway, those are now cool, which means I can kind of, the other thing I can do, here, I'll show you what's going on with that. Let me see if I can turn this on. Watch. When I make a fist, come on. There we go.
Oh, nice.
Like that. So that's what's going on there. Is fist is happening there. The hand, wait, what's going on here? Hand side. Is this left or right? Yeah. Facing forward or back, I added as well. So this is what's used to decide where to draw that, whether it goes on the back plane or the foreground plane.
Yeah.
By the way, for anybody who's thinking, you know what, this still is looking a little goofy, not quite right. I have a couple things in mind. One is to have it kind of naturally change its distance from the hand. Just kind of floating.
A little bit of floating.
A little bit of floating, add that a little bit. So it looks, because right now it's a little bit like, it's a little weird, right? And I kind of want to actually have it follow my hand. So my hand moves first and then it rushes to that
Little
position.
delay. Yeah, that's going to be quite nice.
Yeah, so I'm going to do a little bit of that, and we're going to add sound. So I think when those three things are done, I think you'll be at a point where you'll be like, okay, I'm maybe
It should also smooth when you do that as well, because if your hand is inherently moving a bit more than maybe we give credit for, but it moves back and it moves forth.
Right.
So it goes left, it goes right maybe. And as a result, by the time the fireball is going to move left to follow your hand going left, if you have moved back to the right already a little bit,
right,
that won't occur. So there'll be less movement on the part of the fireball, but it'll be more organic.
Yeah, that's my hope. And I think all I'm going to do is treat that center point as a gravitational point, where I'm just going to apply forces moving towards it at all times. So theoretically, I could even get into an orbit. Right?
That'd be cool.
It might be cool. Yeah, that could be cool. Okay, where's my throw calculated here? Is it in this space or not? Throw, if it's not here, it's in skeletal 2D. Nope, I got something called throwing. Here we set it to true. So this is work that we kind of were midway through before. But the idea is that when the throw occurs, we create a virtual object in three-dimensional space, give it the velocity, and we just track it. And ultimately, we'll try to catch it as well. So we'll try to get a throw from here and a catch to there, like that. That could be like also over the top in terms of selling this. People will be like, what? So we're basically what we're doing is we're trying to take a somewhat challenging problem, right? Almost, you know, I like doing things where people at the first glance are like, that's impossible. You can't actually make a live fireball in your hand.
This is clearly crazy. You are smoking something you shouldn't be.
Right. That could be it. And or it could just be this show. And that's what I'm trying to do, is I'm trying to get it, we're just trying to attack it with as many solutions as we can, right? We're trying to attack the problem from the point of view of sound, from the point of view of believability, like what's in front, what's behind, right? That sort of thing. In other words, when it's behind, that's when things start to look a little bit impossible to me, right? Because the clean lines between the fingers and the fireball behind are cleaner than you'd ever get with today's technology of green screen, right? In other words, you know, are we green screening? You know, when I say green screen, what I mean is identifying where the fingers are and then cutting that out of something that would be on top, right?
Yeah.
I don't think it occurs to people, wait, you've got something behind, especially, you know, in the way I'm going to do it is I'm going to do it over here. I won't do it here. So I'm never going to draw it between my face. You know, if I'm doing it right, I won't draw it between my face and my hand, because we can't do that. It's going to.
That's right. You've got two moving components. You've got your head and you've got your hand, and they're both being drawn on the same plane because the camera's only got that one plane to draw on. So you want to avoid that use case where possible.
Yep. Now I've got this thing called instance index. That's called by Throw. So Throw, check it out. Throw does this. If it returns a non-negative 1 number, it's calling add instance to world, and world is going to give back this num instances created index. It's kind of like this unique indexer for the session.
Yep.
Okay. Excuse me. And that's what's happening. So now we've got these instances in the world. I really don't want to get wet with pudding today. I don't want to
when you've got instances, you add a bunch of pudding.
That was pudding. Pudding, I thought it was clear. I didn't want pudding today. Did not ask for pudding. All right. Welcome, pudding. Glad you're here. Karen says, I want pudding. Hello, Mark and Rory, savior of all streams. I don't know. Today we're kind of like just...
Do you ever get the feeling we're being put on this platform that somehow we have to live up to, and the chances of us managing to seem a little less than... I don't know.
Less than 1.
Yeah.
Putty loves you too, Karen.
There we go.
I love Putty, and Putty loves me. All right, so instances, we're creating what they don't exist. We're adding it, returning this right here. Are these instances used anywhere else? They're not. Now, we need to send the instances down. Virtual 3D object. Looks like this. We need to move these, actually. We need to move these, which means we need a physics engine, a real simple one. We're going to get one right now. By going into this class called physics, this is kind of what we need. We need these methods in it. So let's go to our World 3D. Let's create a new class. I guess I'll call it Physics 3D. And let's see. Let's close this down so we can make changes to it. I'll open up a standalone version of it, just running the exe only, so we still have control over Fred. All right, so this is my Physics 3D engine. I'm going to make it static. By the way, kids, if you are working in VS Code and you're interested in having Coders templates work there, we are working on an extension for you for that. And not out yet, but it is we're in the process of basically, we can't release it until it's really good. That's the stage we're at. So
fair enough.
Dev said, can we do this? And I looked at it and I said, not till you get this done, and we sent it back. And so they're like, okay, and they're working on that now. So we are. So anyway, we're at a point where we're almost going to be able to use it. Now, I should mention that Visual Studio Code, one of the things we found in making this, getting this, porting stuff over to VS Code is that they are not as extension friendly, as I guess I would say, as Visual Studio is. So as a result,
it's interesting.
Yeah, things that we had before, we don't have now, and we're having to come up with workarounds for to get the same features over. And it's a little bit disappointing. Like one of the things that but we're working at it. We're going at it. We're attacking. We're trying different things to work around the limitations posed by VS Code. I think we're going to have some success. So it's not bad. There's also there's good and bad to the decision to limit things like they're doing. Who's that guy? Who's that guy, Fred? We know who that is. It's Coding Gorilla. I'm not a big fan of anything that's Electron based.
So most of the known universe, then.
Yeah, I know. I don't like things that reflect or absorb electromagnetic radiation. I'm similarly. I have strong stances against those things. Also, I'm not a fan of electromagnetic radiation. It's too wide. It just goes too far in both directions in terms of wavelength. All right.
Sure.
So we need something like this. We need some stuff like this. I'm just going to copy this. I don't know. Is that what I want to do? Copy this. I'll come over to our D&D app and our Physics 3D. I'll paste that in. And let's just kind of build these pieces at a time here. So we're going to have a method that returns, should I work with doubles? Why not? This is going to call meters to pixels. And that's going to take in some meters. And somewhere in here, we're going to have something that says pixels per meters. I'm going to make this a constant. And I don't know what I had down below. What I have down below, I should probably use that. When I say down below, I'm referring to my TypeScript application. It's 50. Okay. That's what I got. All right. So we've got this. And the return is going to be return meters times pixels per meter. All right, one down. Next one. Got this, and we've got a pixels to meters now instead.
So the place where you copied this code from, Mark, why are we not using that rather than the recreation, I guess, in a class here?
It's TypeScript, and I need it in C#.
Oh, of course it is. Sorry, I'm just looking at curly braces here and there, and I'm thinking, yeah, it's all the same. But of course it isn't.
It's not the same.
That's quite a silly assumption on my part.
No, it doesn't. Not at all. Don't worry about it. They look identical. What's going on? Right. No, I'm glad you asked the question. It was actually a great question. All right. So now we're going to have something that is going to return the displacement in meters. It's going to have the time coming in. It's going to have the initial velocity coming in, and it's going to have the acceleration. Now, all of this math is all happening in one-dimensional space, okay? And what we want to do is we want to make it work in three-dimensional space. But it's not too hard to do that. Here, I could probably copy all of that and paste it, and I get my formula, I bet, and this code is the same. There's no change here. I'll just do a 2.0 there just so it's very clear what's going on. All right, so that's cool. TypeScript is just the same as C# in terms of that return right there. Let's do the same thing here. So the MD gives me a method that returns a double. VD is going to give me my time. VD again is going to be a variable of type double again, and this is going to be my initial velocity. I'll just drop a marker there, come down here, copy that, jump back up, paste it, and then we're going to have also another double here. called acceleration. Okay, and I'll just copy this code down here too. That'll give me my nice sweet formula. That's using a CodeRush feature that does math, that supports math, MathML in comments or latex math comments. Get drop time in seconds. And height, maybe we'll just call this distance. Meters. Acceleration and initial velocity, like that. And we'll grab this and put it up there. And we're going to use distance meters instead of height meters. All right, and math square root looks like that with an uppercase. And there, we got get drop time in seconds. Is that it? It looks like that's it. Okay, so now we've got our physics engine. Let's make these public. Cool. We've typed file. It's my physics 3D. Well, it's actually, in fairness, it's physics 1D.
Yeah.
I'm going to just change it to physics. I think I kind of want to create some extension methods for vector to allow it to kind of give me the 3D math that takes care of this. Because basically what happens is we're going to need to make calls like this, or maybe this one down here. Let's get them C#, adhering to C# naming conventions. We're being, again, public methods with a uppercase letter. We'll make calls to these for each of the 3 dimensions, X, Y, and Z. That's what I'm expecting to have happen here. All right, so now we need, I think we need an update method right here. So it's going to be method. We're going to say update positions. We're going to just update. We're going to pass in a time, like that. And virtual 3D object is created. Time.now. I wonder if I want to change that to ticks. It's not telling me how big a tick is. I think it's like smaller than a millisecond, but I'm not sure. If it's a millisecond, I'm totally perfect with that. What is a tick?
I used to think it was something like a 60th of a second, was that? Where am I getting that
No,
thought
I don't
from?
think it's so. I think it's smaller than that. Let's go see what a tick is. How long is a tick? Long is a tick?
100 nanoseconds.
Yeah, all right. There are 10,000 ticks in a millisecond.
Okay, that's quite a few.
All right, so we're gonna. I want to do the time down to milliseconds. So I think I'm going to say divided by 10,000, divided by ticks per millisecond. 10,000, like that.
Now, Mark, down in our TypeScript, we've got a convention, at least for part of it, that says when we're measuring time, when we have duration, we actually have an ms suffix for milliseconds. Are we going to use that here, or is that not so much of an issue?
You mean like that?
Yeah.
Absolutely.
Because I know that we do have other times where we previously were using seconds, and of course the two met up, and it was like, oh, hang on, whoa, they can't be done without a bit of a multiplier in place.
Okay, I've got it. Let's see. I want that, but I want to do a math dot round on that. So I think that's what we're talking about. The long is we just need an integer, right? And the long is an integer. C# long.
It's a big integer.
Yeah. Is there a bigger one than that? N64 is bigger, or no? Or is it N64?
I think N64 is the larger. Because
Big N?
Michael Jolly is in the house.
Hey, Michael Jolly. How you doing, my friend? N64. Name can be simplified. Is that going to give me a long? Is it going to go back here? Where does it simplify? Yeah, it's a long. All right, fine. So that's what we're going to do. We'll make our creation time in milliseconds be that. So we got plenty of time there to deal with that. Then when we come in here, we're going to say this time is equal to time ms. That's going to be my update call. Now I want to go through all my instances. For null, I want to get out of here. Then I want to do a for each. And then I want to say virtual 3D object.update. Who's here?
Is in the house.
Pass in the time. Seconds. Right like that. Surly, welcome. Bald Bearded Builder, welcome. El Grande Int. Free Pumpkin Soup. Surly was here over the weekend where we had, if I'm recalling correctly, we had some Halloween pumpkins on that day.
nice.
We're broadcasting and you're here next year. I'm going to make you a brand new opening intro with more pumpkins on it.
Ooh. More pumpkins.
My maths are wrong. Are we sure my maths are wrong? Let's go see. I think I have 10,000. If 10,000 is equal to
so we're trying to get the number of milliseconds. We know there are 10,000 ticks per millisecond, so we take ticks and divide by.
I think it looks right to me. Should be
Should be
star?
multiplied, not divide, he says.
I don't think so. 10,000
So
ticks.
let's say it was 1 millisecond was the actual amount of time that went past. That would be 10,000 ticks. So we take the 10,000, divide it by 10,000 ticks per millisecond, and we'd arrive back at 1 millisecond, wouldn't we?
Yeah, I've got. So wait, Coding Gorilla is saying this, not Surly Deb. I thought Surly was saying that. Yeah, no, you're right.
He's changed his mind, perhaps.
You're my favorite, Coding Gorilla.
Do you know what? It's worth making us reconsider that stuff because we have got that wrong before.
Yeah, no, and I would emphasize the word.
Thank you, anyway.
I would emphasize the word worth from Rory. Making suggestions or double checking things all the time is really, really valuable and powerful. And I welcome it, and I consider it valuable all the time. Even if, right, it turns out to be incorrect, it's still incredibly valuable. Because the alternative, I suppose, is to, hold back ideas, and double check things. I'm a huge fan of this. By the way, not a lot of people I know are huge fans about it. Like nobody likes it when I'm like, most people don't like it when I'm like, wait, let's double check that. And then, it turns out they were right. And they're, a lot of people's reaction is, see, I was right or whatever like that. And I'm like, hey, no problem.
I feel like
double
it's an
checking.
advantage going into a problem-solving situation, comfortable with the knowledge that you could be wrong.
Yes, but
Right?
also
You have to be about
Right.
taking on board additional ideas.
Also, though, this is now, we know way better than it was a few seconds ago before Coding Gorilla asked a question about it, right? Because a few seconds ago, we thought it was right, but now, after going in and examining it, we now feel much better about it, right? And we've got consensus, and now we feel, now we know it's right? Now we feel really strongly this is right. I've got 3 different people that are like, nope, that seems right to me. So that's good. Okay, so we need to get an update in here. That's what we need to do. This is where we're going to start working on that physics, I think. And it's... I need to know gravity in the Y, but only in the Y. In gravity in the Y, we're going to, I guess we're going to play with Earth's gravity. We're going to create a constant here, I think. We'll say gravity is equal gravity meters per second. It's equal to our good old friend 9.8. Excuse me. There's our gravity meters per second. Then I want to go into my physics, and then I want to say get displacement meters. I think I want to change this to start position. That's my start position. Is what I want to do. Oh, virtual 3D object. Yeah, I'm not sending this down, so that's okay. I can make whatever changes I want here. This is my velocity vector, and I'm going to change this to initial velocity. Like that. Are we setting this anywhere?
Okay.
Yeah, we're setting it to the throw vector velocity. Sweet. And then now what I want to do is, I think the call I want is to be, I think I want a current position vector.
This is good. You've got a start position, you've got a start velocity, and you've got a creation time. So what you're doing is you're going to have a calculation that based on the current time is X different in all of these three things from where we started.
Yeah.
So it doesn't matter when you evaluate it,
right,
or how frequently. It's when you do get around to evaluating it, you have all the components you need. You don't need to refer to the previous iteration, just to the start point.
Yeah, that's what I agree with. Here's what I think I want the code to look like. Get current position. I want to call it position. I want to call this on the vector, the start vector, and I want to pass in the initial velocity, and I think I want to do time ms minus creation time ms, and that's what I want the call to be. What do you think about that as a call? Well, I need gravity as well.
Yeah, so you've got your initial velocity, you've got the length of time that needs to have, that effectively the force has been acting on that initial velocity, and you've got the force itself, which is gravity.
Yeah. You know what I think I want to do? I want to say, I want this to be a vector here, and I want to call this the gravitational gravity. I can go ahead and do this, meters per second, but now I want to do this. I want to say it's equal to a new vector, and I want it to be, that's what I'm looking for, 0, comma 9.8, comma 0. It looks like we're working with floats.
Right, so it's specifically now a force acting down.
Yeah.
In fact, is that supposed to be where's the origin as far as these things are concerned? Is it high and positive Z takes you down? Sorry, positive Y.
Well, you know what, Rory? Instead of calculating that in my head, I'm going to run it. If this falls the wrong way, I'm going to come in and do that.
I like that. That's a very, very effective way of getting it right.
All right. So now we're going to come in here and say gravity. I don't know. This meters per second is pretty big to me. I'm just going to come over here and comment and say meters per second, like that. And so now we're going to say set current position. See if I can duplicate that. Okay, look at this. Hold on, I want to get a, this has happened before. I want to bring this up. Let's report an issue on this. All right, kids, look at this paste right here. See if I can reproduce this. Paste. Why is the caret on the left of the paste item I'm pasting? Right? Paste. It's totally reproducible. I hope you can find something in the logs. I reported this problem like a while back. It's rare, but it's happening to me right now. Totally reproducible. Just paste, and there it is. It's totally in the wrong spot. I come over here and paste. It's in the wrong spot. On an empty line. It gets to the right spot on an empty line. That's good. If I put something in front of it and paste, nope, it puts it to the left. What is going on? That's my question to you. Let me mark it down here. Paste. Moves caret to front of text change. See if you can find that out, kids. What is that? All right, closing that up. Okay. All right. So that's the code I want right there. Let me clear this, kill that. I want code. I want the code to look like this. Current position is equal to start position dot get current position. I think. So my question to you, Rory, is what do you think about that from a calling standpoint? Do you think it's like a name? Or are you good with that? Should we
get current position is pretty good, yeah, because absolutely implies now, and it is physical position we want. Gravity is going to be a relative constant in this, so that's fine. So it's effectively get current position given these facts.
Yeah, so that's what I want to do. Now I'm going to create a new class called. Actually, I'm going to use an uppercase C. That's going to give me a static class, and then I'm going to call this vector extensions. And I want to create a new method in here called get current position. It's going to work on a vector, and it's going to take in another vector. Do I have this? Do I already have this? So I'm using this as a template. Do I have like TV is going to give me a vector? I do not. Okay, TVC. I'm right-clicking this. There's no use type of templates. Let me go check to see if this is, because I've just got a shortcut for it that I'm not remembering. I'm thinking about a new feature. That's what I'm thinking about. Got V3 for vector 3 over here. Can I find vector on this page? Wouldn't that be awesome? Yeah, I'm not seeing vector in here. Yeah, I think I'm going to do a coder's feature request from here. Oops.
Where does vector come from?
That's coming from Leap, pretty sure. That's Leap's vector. We can double check that in a second. Hey kids, I'm trying to, I want to create a template name variable for this. I right click, and I'm not seeing the option to create a template name variable for this vector right here. And if I go into the options dialog and I click on template name variables and I come over here to neutral, I got so many in here, it's really a lot of work for me to find if it already exists. I feel like we need to search. That's kind of my feature request, to be able to look, to type something in here and be able to find anything on any of these pages, including maybe another language page. So it would show you which ones it found here, but then also say, you know, entries found in these other languages as well. And then you could just click on that link and get to those entries and see them. Right now, if I come in here and I do look at my custom types, I've got a vector 3, but not a vector. This is in a different class. And so I'm looking for vector, can't find it, not sure where it is. Yeah, so that's my feature request. Okay. Let's put that in there. Add search to template variable names option page. Put that in the chat. You guys will get that. All right. You can add
Mark,
it
is
manually.
it not working because this keyword's supposed to be on the left of the type in an extension method, not
Is
the
it
right hand
really?
side?
I think it's. I'm pretty sure.
I think it's
here.
this type name.
I think it goes like this. Let's see.
If it wasn't an extension method and you went vector, my vector, that would work. But I think it's this vector, my vector.
Oh, you're right. Look at that. Tell the devs to kind of. Well, that's the. It looked like there was maybe a bug or not, but yeah, use type and templates. It would have been nice to still have the search. I still want the search. So,
Search is good, yeah.
So that's what I'm looking for right there. Vector. I'm going to say VC and add that. That's what I want to do. I think this syntax is right, if I'm recalling correctly. The next thing is now I want to type in a VCT. Oh no, wait, VVC like that. Why isn't it giving a comma here? And this is going to be gravity.
There's definitely something wrong with that because
Sure
you don't
is.
have a name for that first parameter.
I thought that this was the name. Get current position has a parameter modifier this, which is not the first on the first parameter. So this goes over here,
I
and
think you say this vector and then I have a habit of calling mine source, but you can do obviously whatever you like.
that's how it works. Huh? Okay. Yeah, to be honest, I used to use CodeRush to create these all the time in CodeRush Classic. I don't think we've ported this over yet, so I was like, well, let's just do it by hand. But yeah,
Fair enough.
I thought we could just call it just the this, but I guess you're right, we can't. You say don't talk to me? Is that what you said? All right, our initial velocity is going to be a vector as well. And then we're going to have a time, which is going to be a long time.
Is it
MS.
duration or time? Yeah,
Yeah.
time MS is nice.
Yeah. What do you need, babe? Okay, cool. Glad to hear it. You just want to stop the show, kill my energy, just to say you don't need anything? Slow it down. Hey, can you refill that for me? Be a good wife. Take care of me. Make me a sandwich. Give me a beer. Can you do that? I don't drink beer. She's not gonna. She just took my water bottle. I'll never see it again. What's the wrong here? Vector's not contain no accessible extension method. It needs to be public. How's that? That. Convert from double to long. This is going to be a long. All right, that's not bad. We've got at least now the piece we need declared correctly. Thanks, Roy, for your help on that with this. Okay.
I should point out that my knowledge is not universal. I just happen to have a copy of Google in front of me.
That's perfect. Thanks, David. Okay, so now what we need to do is figure out the displacement for all of these pieces, I think. So we're going to say, we'll work with floats, so we're going to say displacement x, we'll go ahead and calculate it, is equal to physics dot get displacement in meters, and we want to pass in the time, which is going to be time ms. This is my delta time. Like that. And my initial velocity dot x, and my acceleration, which is going to be 0. Well, I'm just going to use it. It's gravity.x. Like that. Now, that, what's wrong here? Double the float. Fine. We're going to switch us all over to working with floats. Time is going to be, yeah, we're going to do the float. This time should be in seconds. Okay. All right.
Yes. Good point.
Yeah, keep an eye on that one, Roy. I think I'm going to miss that.
That's an easy thing to forget because the equations themselves are supposed to be in seconds, but we're used to dealing with milliseconds.
Yeah, okay, so now we've got our physics engine working only with floats. That can work. This part looks like it's working. Let's duplicate this.
Except that's a delta in milliseconds, and it can't be.
There we go, delta in seconds. So we're going to do a delta seconds. That is equal to delta time milliseconds divided by 1,000.
Yeah.
All right, do you agree with that, Rory?
That's good.
And we're going to need to cast this to float, I think. Like that. That should work. How we doing? No? Oh, must be a constant? Like that. Okay, that's the problem. Okay, did I need the float? Looks like I didn't need the float. Just another problem. Okay, so delta seconds is now going to come in here. Now let's duplicate this. There's my y. And let's change this y and this x as well. Duplicate it again. And good, we've got the z. So now I've got the displacement for all of those. And now I want to say, get current position. Does this return? Yeah, it's got to return a vector. So I'm going to say return a new vector. And we're going to pass in the original vector position plus displacement x, y plus my displacement y. I should be able to select this and duplicate it. There you go. And get the rest. Okay? So get current position is now going to do that. That's going to assign it to our field current position. So that's in my update. I'm feeling pretty good about this.
This is nice because, as we said before, this allows you to do this at any rate that you want, effectively not tying ourselves to a frame rate, which is, again, the objective here, and to know the precisely correct place on that arc where the thing should be.
We have one problem. Just curious, to use long instead of time span. I don't know. I just wanted some. I wanted a counter for milliseconds. That's what I wanted. But in fairness, you know, it's a great question. I'm now thinking.
I think it's regularly easier to use the long because otherwise you've got to construct a time span.
Yeah, but it's also we're basically saying our accuracy of our. Our equations is going to be granular to the, depending on how close the time is to that millisecond, right? In other words, between millisecond kind of options really won't be there. So, in terms of accuracy, we're going to become less accurate as we get closer to the, the time.
Right, because duration, although more complicated, could store things down to the tick level.
Yeah, we've got another problem too. It's just occurred to me is we're getting displacement in meters. We need to come back and say, meters to pixels, right?
Yeah.
So there's this conversion back.
That'd be good. That could give us some wildly weird results otherwise.
But realize that when we're dealing in the 3D space from the LEAP motion detector, right? We're dealing with this space out here. This isn't really even pixels. It's in something else. It's in these kind of universal LEAP coordinates. So this conversion, whatever it is, this meters to pixels conversion that uses this pixels to meter piece right up here, we may be changing this number to kind of get this to kind of fit into what we want. Right? So that's kind of what's going on here. Yeah, the numbers we get for X, Y, and Z are definitely not meters. They're definitely something else.
Right. I mean, that does call into question the accuracy of this entire bit of logic, doesn't it? We're going to need to know, because we're definitely presuming we've got seconds which are accurate, but we don't have meters that are accurate, but we have a force that's accurate in meters per second.
You're right. Well, we have two things we can tweak. We can tweak this number, and we can tweak wherever we're passing in that 9.8. We tweak that number. We tweak both of those. And I'm not afraid to do that.
Where does our initial velocity come from?
From the throw. So if we tabbed an X reference on initial velocity, we're basically getting that from. Yeah, so I know. I love your question. What's the unit? What are the units of that? Right?
Yeah.
I don't know. But I'm not afraid to tweak the numbers because it only has to work in this space right here. All right, so let's look at update needs along, which is our time in milliseconds. And I think since we're not calling in here anywhere, I'm just going to change this to along as well. You know, so I'm not too worried about it being along. I don't think we're going to see really any evidence of any problems. I was just thinking milliseconds. How many milliseconds is it apart? That's what I'm doing. But yeah, I could do it as well. I could send a date time inside of here. Let's play with that. Like that. Let's pass in time here. Update. It's going to be time. This is going to be of type date time. And now what we want to do is we want to say creation time. We're going to mark this as a date time.
Mark, I'm reading some documentation for the leap motion suggesting velocity is measured in millimeters per second.
That's awesome, buddy. That's a great find. Cool. So creation time, I'm just going to come down here and say DTN. Yeah, it simplifies the code, Smoothie. Good idea. So then creation time was that. And then now, what's it looking for? Delta time in milliseconds. So we're going to say the current time minus creation time, put parens around that, and then say total milliseconds, right? That's what we're passing in delta time ms. But, you know, why not just say it's delta time in seconds? And why not make it a float? Like that. Because it's just as easy out here to say total seconds.
To be honest, you could just have the duration pass in period, if we have that, and then work out the seconds inside.
Okay, I like that. I do like it better. I think it makes this code easier to read. So this will be a time span.
Yeah.
Like this, and this will be delta time. I'm liking it better. I think this is a really great suggestion, Smoothie. And now then we're going to create a float. Call it delta seconds is equal to delta time dot total seconds. And we got to typecast that as a long. No, as a float. I mean, like that. By the way, CF is a great short template here for casting to float. It's really nice. Okay.
Like that, yeah.
All right, so now we got and we designed the heck out of this. I kind of like this, right? So it's sometimes we write code and test, and sometimes we design the heck out of the code and before we test. So now we've got an update call, which is not being called, I think, anywhere, is it? Oh, we are. This is the update here, but this one's not being called from anywhere. Like that. So we want to go to our World 3D and we want to call update. We want to do it before we get anything out of here. So World 3D is here in skeleton data. Got throw, world add instance. All right, where are we calling the Hubtastic base station update call? It's not called from here. Let's go into our Leap device. We're calling it here. Here it is, right down here. Okay, so when we throw, we call system media sound, system sounds beep when we play it. So we're going to make a little sound when we do the throw. You hear the little dung dung kind of beeping sound. We're going to send the data out. I think what we need to do is we need to say, before we send the data out, we need to say skeletal data 2D dot update virtual objects. Like that. So again, if you're kind of wondering what's going on, when I do the throw, when I throw the fireball, we're going to create a virtual object and we're going to give it a velocity and we're going to track it through space. And hopefully it'll all, that's what our goal is. And while it's not in a hand, it won't follow the hand. It'll instead follow the virtual object in space, which we're tracking in 3D, and we're going to have to map it to 2D and send the 2D map down with the skeletal data. That's ultimately where we're going. So we're going to call update virtual objects. And let's declare that. And then we're going to say world dot update, and we're going to pass in the date time like that. And I think that solves that part of the problem. Now, we also are going to need a timer, because I might throw and the hand data for whatever reason may not, like I might throw it up and then bring my hands down. Once I bring my hands down out of screen, we're not getting any more hand data from the Leap Motion device. And when that happens, I still want to have the thrown object continue to move. So So what I want to do, so funny, like while I'm saying this, Roy, I'm thinking, oh, this seems really advanced. I wonder if this guy will be able to do it or not. And I'm like, wait, that guy's me. Yeah, okay, so we're going to throw that up. Let's try and stay focused here, kids. I'm talking to me on that. So we need a timer. And we need a timer once we start throwing something. So I need to find out when throw is first set to true. Check for throw, here. So check for throw is there. I think this should return bool. And then we're going to say this is going to be a return true right here, and this is going to be a return false, like that. Okay, so check for throw. Now I want to do something like this, I guess. Need timer, so false. Then we're going to say if check for throw, then need timer is equal to true. Then down here we're going to say, hey, if need timer, we're say create timer if necessary. So this is going to or alternatively, should I just create a timer flat out? It's so much simpler to just create a timer instead of destroying it when we don't need it and creating it again. From a performance standpoint, that makes sense, but I think my machine can handle it. My machine is like, you know, oh yeah, throw more code at me, Mark. All right, maybe I'm going to do that. Maybe I'll come in here and I'll say, I'm going to get rid of this, get rid of that. Not going to do that. I'm going to create a timer flat out. That's what I'm going to do. Now, we are in we're not in WPF here, even though it's connected to a WPF app. So I think what we need is inside system dot in threading, system dot timers. That's where I want it to be. And then we need to have a, I'm gonna have to look for help on this. There's so many different timers out there. C# system dot timer example.
Do we actually have to make a timer just to get the time?
I want something that comes in and triggers. We need to update. We need to update. We need to update.
Oh, so it's the recurrent aspect rather than what is the time. Okay, yes.
Yes, that's what I need to do. Here's my example. The timer to get the time. Yeah, it's just a new timer on elapsed. I'm not sure what auto reset is. All right, so let's do this.
I feel like I did know that one.
You feel like you did know that?
Yeah, that's on the top of my
timer? Or
I think
elapsed,
the point
elapsed?
is that it recurs rather than, elapses once and stops.
The interval.
Is that what it is?
I want this to be. I want to say at least 30 times a second. And let's declare that. That should be actually, the interval is probably what, an inch or something? What is a double? Okay, so we're going to put a constant to type double, call it FPS 30, and that's going to be equal to 1000 divided by 30. So that's going to give me my 30 frames a second right there, if my math is right. In milliseconds, yeah, interval in milliseconds. Okay. And where is the, I don't understand why I'm not seeing the event on this. Elapsed, did I miss it? It's not here.
Have you got events screened out of the IntelliRush?
Nope. I'm not seeing it in Visual Studio either. Add items from unimported namespaces. Only properties. I'm not sure what's going on. Similarly, I can't hook the event, I bet. I can't hook the event in the initializer. I bet that's what it's not allowing me to do. That feels like potentially, possibly reasonable. Okay, so now we're going to say timer.elapsed is equals to that. And then at this point, I want to just be like, did we set it equal to enabled or not? Like that. Hold on a second, really. Okay. Timer elapsed. Okay, now at this point, I think we want to say, hey, if let's fill this out later. Okay, but soon. We're going to deal with it soon. I need here in update virtual objects. We need to go through And we need to go through all of the instances. If world.instances equals null, then we're going to, I think, return. I think we need here in skeletal data, we need a list of the objects we're throwing.
Okay.
And I'm not sure if I created this or not. I have a scaled point. I need a scaled point, which is converted to 2D space of the object we're throwing. I need an index for it as well. Let's go down and look at the TypeScript code and see if I've added this down here or not. Looks like the answer to that is no. It has not been added yet. Okay. All right, so what we need to do is we need to create that class. So we need a class that is going to be our virtual object, I guess. Thrown object. Thrown object. And it's going to have a scaled point. So that'll be its position. It's going to have an index as well. That's that unique index we're giving to that object. And I think that's it. I think that's all I need for thrown object. So let's move type to file. And let's go back to, let's just pick up our markers here, right here. So now we need inside of here in skeletal data through 2D, we need a list of these. Like that. And that's in our skeleton data through 2D. Over here, do I have a skeleton data 2D? There it is, right there. And it's going to have thrown object. Let's go find that. That's over here. Remember that template 2JS we created? There we go. It just built that code for me based on that class we were in. Okay, so there's our thrown object. It's got a position, and we've got these thrown objects that we're bringing down. All right.
Looking good?
Yeah, well, maybe. We'll see. There they are right there, thrown objects. So now we're not doing anything with these, but in the update virtual objects, I'm suggesting that we do something like this, set it to null here for every call. And then if we've got some instances, that count is equal to 0. Oh man, let me get the spaces right here. Then we're going to return. Otherwise, we're going to say thrown objects is equal to new list of thrown objects. Now, I'm a little worried about performance from the standpoint of creating a new list here. You know, so many times every second.
Yeah.
Essentially talking about creating a new list 120 times a second, up to that, about that point. So I'm like, oh, do I really want to do this? Maybe I don't. In fact, I'm now knowing I don't. I want to instead initialize this at the beginning because the constructor can sometimes be a little bit expensive, right?
Yep.
So I'm going to just initialize it here, and then we're just going to simply clear it here.
Okay, yep.
Right? I think that's going to be more performant. And then what we're going to do, we're not going to need to initialize this here. Now we're going to go through every instance. And we're going to say thrown objects dot add virtual 3D object dot current position dot no, let's do this. To thrown object. Like that. We'll do that because we need the index on this thing too. So let's go do that, declare that method. And now this is going to say I wonder if I want to have a thrown object here. Set it equal to new thrown object, like that. And then if I want to say, so instead of just creating this every time too as well, no, maybe I do it here. And I don't ever do call to thrown object. And so here I say thrown object dot index is equal to index. And now I'm not liking the fact that I'm storing this in two different places. All right, I'm going to expand the setter and the getter of this. I'll do this, but I'm going to get rid of that and instead go to the index of both of these. So I'm going to store it, that index, up in here. So whenever this is set, the thrown object index will totally be set. Then all I need to do down here is whenever the position changes is come down here and say, hey, thrown object dot position is equal to current position dot to scaled point. And then we're going to go into vector extensions. We're going to create a new method that returns a vector. Call it to scaled point. And then we're going to say oh, and I want this to return a scaled point. Okay. So that's going to, every time we call update, that's going to update the thrown object's position. Let's get out of here, back to where we were. So now we're just going to say add the thrown object. Good. And I feel like that's now got all the objects that are being thrown. Now let's go switch over into TypeScript. We're not using those yet. somewhere in here in hand 2B though, I think we're looking at throwing. So check for throws. At this point, we're throwing. The hand following data is the data that we're storing with the sprite that represents the fireball. Also for the fireball, the flames that come up over the front, those are not anything we're tracking. So once a flame comes up, it just goes up even if I move the fireball away. That's what gives us this kind of ability to make it look like it is, the flame is following where the hand's moving.
Yeah.
But now if we're throwing, I think I want to go into hand following data. And I want to say, hey, hand following data dot is thrown, set it equal to true. And then I want to do something like the throwing index, tracking object index. Oh, cool. I've got one. Is equal to hand dot, what do I got? Throwing object index. Sweet. Okay. Yeah, this whole thing, this is like a week of, you know, inserting a week between development day 1 and 2 is a little bit tricky. But I'm like, oh yeah, I was thinking about this. I got the name here right here. Yeah. So do I need, I guess my question is, do I need is thrown to true if, like, say, for example, my tracking object index had like an initialization of -1, which it looks like it totally has. So
Sure. So that in all circumstances, you could derive the same information from the fact that you now have a thing you are tracking, and you wouldn't be tracking a thing unless it had been thrown.
Yeah, if I've got that index, then we're now throwing it. So
now the only way that doesn't work is if for some reason you start tracking a different kind of thing later. Okay, so
I think it'll
you
work.
know,
I think
it should be fine
there.
because I don't think we have any plans for that. If we were going to do that, we'd rename this to sort of thrown tracking object, and then we'd have another tracking object for whatever that other thing
Right.
was.
All right, so now update tracking effects. It's really, this is just going for the first sprite. Add support for 2 or more. Add support for more. One of the things I'd like to do is be very explicit so I can bind my comment to the code in case these two get separated later.
Yeah, and it does happen all the time. You sort of move your code down, you don't necessarily think of it as being attached to the comment. Now that because you've got something embedded in there to talk about exactly what you were referencing, that's all good.
Yeah. Okay, so I'm getting my sprite. My sprite's got its hand following data. Then I try to get the hand based on the hand side. But I think we can also do this where we can say, hey, look, if the hand following data dot tracking object index is greater than or equal to 0, then we got a situation where we want to, the position, we need to figure that out elsewhere. So let's see here, showing hand speed, update tracking effects. Let's start refactoring this here. Okay. Get virtual position from index. This is the, oh, look at this. We've already added the code right there. That's what we wanted. That's what I wanted to do. Okay, so let's kill that. Get virtual position from index. Is it doing anything? It's not doing anything.
Not a great deal, no.
Not a great deal.
But the framework is there.
The framework is there. So what we want to do is say this dot thrown objects. I think I want to do, I got to do a for loop. Like that. I might do something like this. I might say, hey, look, if not thrown objects for thrown objects dot length is equal to 0. Then we're going to return this like that. The reason I didn't do a for each inside of JavaScript here, which is normally my preferred way to do it, is that any return statement in here isn't going to, oh, I wonder if that would work. Could I do that? If I said return the result of this. Any return statement of here just gets out of the for each and it keeps looping. So I kind of want to get out of there faster. John Calloway, good afternoon. All right, so here we go. Skeletal data, thrown objects. I want to say, hey, look, if this thrown objects of I dot index equals the tracking object index. By the way, you learn this in the Mark Miller School of Dance. It's one of the advanced moves we teach on the dance floor. It's how I got my wife. Used the Mark Miller School of Dance moves on her. That may not be a true story. How's the AR going? It's good. I'm arguing that this is a special kind of AR. It's augmented live video is what it is. A little bit special here. All right. Well, we're about to test to see if I can actually throw. I think it's going to go miserably poorly. Is what I think it's going to. I think it's going to be like.
Well, we still haven't adjusted for the units of velocity that Leap Motion has.
Oh, you want to guide me on that, Ari?
I think we just multiply by 1,000 because it's millimeters per second that it'll give it to you, and we want it in meters per second.
All right.
So 10 millimeters to the centimeter and 100 centimeters to the meter.
Let's go.
Or actually, it'd be divided by.
Remind me to do that before we test. Let me finish up this. So now I'm going to say, hey, look, here is, if this index matches, then I'm going to say return that dot position. Okay? And then down here, I'm also going to come down here. If we get out of there, we don't find it, we're going to return out of bounds point. Okay? So there, we're getting its position. And it's all of that. Now, hold on. Here, it goes out of bounds. We clear the sprites.
Yeah.
This is one thing I haven't quite figured out how to do yet. We'll have to figure this out. Maybe tomorrow is my guess on timing. But when the fireball gets out of bounds, how do we clean it up from both sides? Because right now, this kind of will clean up the sprite proxies. We're not going to see it anymore. And if we don't see it anymore, we're not going to be able to, come in here and get this code. This code won't work. Has tracking effects is going to check the length of that sprite proxies, right? Is there a sprite out there? I think we're done in TypeScript, by the way. I feel like we are kind of done. We're about ready to test. Let's go back up to C# and make that last change to the velocity. What's the best way to find that? Probably in through physics. And get displacement in meters. Now, the initial velocity is here.
So because it's a Leap Motion vector, that's coming in millimeters per second.
Here's what I think I'm going to do. Got it? You with me? Then I'm going to go...
okay.
Then I'm going to go to my extension methods.
What type are we going to produce from that?
A vector. So
it's a vector that's a Leap Motion vector. Because we don't have another kind, do we?
Yeah.
Okay.
That's what we're going to do. And we're going to say return new vector, and we're going to pass in I'm going to call this leap vector right here. Leap vector in millimeters per second. And then we're going to say new vector dot x divided by 1000.
Yep.
You with me? I'm going to select this whole thing here, shift enter on it, Coders builds the rest of the line.
Gotta love that.
It's good. I might do this as well. Introduce constant for all occurrences of 1000, and we're gonna. Why didn't it do it locally? I want it to be a local constant. Try one more time. Introduce constant. Local constant. That's what I want. Okay, and then we're gonna say mm per meter, like that. All right, you agree with that code?
I do indeed, yes.
All right, so we've created some extension methods here. We've got a call on velocity. That's the leap velocity, throw vector, add instance. Yeah, let's change this to the leap velocity as well. Up here, we're going to call this leap velocity. Millimeters per second. All right. Dare we try it?
Sure, why not?
Or should we just end the show?
Ooh, keep people on the hook for next time.
Yeah.
There's a theory.
That's the theory. You're right. You're right, sir. Let's refresh the overlays. Refresh a lot of these here. Hold on a second. Refresh one overlay. Refresh another one. I'm having a problem because it's making them really big and I can't get to the refresh button because it's off screen. It makes this thing giant for some reason. Refresh that one. And let's see if I can be lucky on the last one. A little bit. Okay, so I've got those right there. I need to rerun this app. Oh, we're not setting. When we update, even though we're updating position, we're not actually going back and calling the SignalR command to send the data down.
Oh, okay.
And we need that somewhere near where our timer is, which I think, is it in world? No, I think it's in skeletal data. Get a timer here. There it is, right there. The timer elapsed. Oh yeah, we're not doing anything at all in timer elapsed. So we kind of need to do that. Let's bring this up here. Yeah, so we'll deal with that later, like we said. So I'm going to come in here and say active. Take off my wrist straps. So we can get a fireball going up in here. All right, I got a fireball. Let's throw it. Okay, it went up, but it hasn't come back down. Oh, it could be because I've got gravity upside down. Let's try again, see if we can get a fireball here. Over here, why are you over there? It's on the wrong hand. Sometimes Leap sees two hands because of the way my hands are positioned here. Hold on, fireball. All right, so there's my fireball. Going left, yeah.
Definitely gravity goes the other way, yeah.
Yeah, gravity seems to definitely be going up. So let's fix that. Why am I not finding gravity here? Where did I put it? I put it in World 3D. Physics. Well, I can do this. Get displacement meters. There's gravity. Get current position. That's why I don't see it. Okay. So let's set a breakpoint here. And let's make it negative 9.8. And put a breakpoint and run it. All right. So right now we get a fireball. Now throw. Okay.
Well, it's definitely falling down now.
Throw it up. It's not bad, but it's really not. It's not getting the velocity.
It's not. No.
If there is velocity, it doesn't feel like there's much. The other thing is we've got this thrown object here. Our update's still being called on it. What's my call stack look like? Hands moved. Okay, we got the hands moved. I just want to try to get a sense of what the initial velocity is, see what that initial velocity is. Gravity seems to work on it though, in terms of when the rate that it falls, it seems like it's working in a scale that's about what we're looking at, right?
Yeah.
What we're expecting to look at. The thing that's really kind of bizarre here it feels like we could certainly increase the velocity by tweaking this. You know what I mean?
Yeah.
So let's see if I can get another.
I'm wondering if my value for velocity is maybe tied to a particular version of the SDK, and maybe altered in the version we've got.
I don't know. Looks like I just lost it. What? I lost control over it. It's just burning above my head.
That's just decided your head is a hand.
Okay. What am I doing? I'm hitting fireball button. We're on fire. I'm hitting fire. Oh, look right there. Looks like nothing's happening. Okay. Can we get it back? And somehow now we're in a great, horrible position here. There's a fireball right there. All right. Okay. Set a breakpoint again. I'm going to tweak this till it feels right, just to see what we get. Okay.
Cool.
So there is that. What is my velocity? Negative 36, 774, 500. Well, I can certainly do that. Let's see what happens. Didn't really seem to move. Squeeze me another fireball. It went the wrong direction. It got bigger, it seemed. Didn't it seem bigger?
Yeah.
It's kind of a little bit weird. Well, this is not as impressive as I thought it, as I was hoping for. I'm hitting the fireball button. Where's my out of the breakpoint? Okay, here we go. Up. That wasn't bad.
That was better.
Yeah, I was careful about the way I threw it. It's when there's a Z kind of thing going on here. Throw it at you. That kind of looked not bad.
That was good. Like that.
Yeah, it shows up over here though. I'm trying to figure that out. Why is it
That's a strange side effect, yeah.
Boom. Oh, I think I may know why. Because we're returning out of bounds point, which maybe over there or something like that. Maybe not. That one's not bad. I want to throw it off to my left though, over there. Okay, that's not bad too.
Go left.
But it was drawing it on the back because of where this is. The decision on what plane to put it on needs to change if it's in the air. Okay, so let's go figure that out. Here's the update. Here's the decision on which plane to draw it on. I think I'm going to do this. His throne, maybe? So if we're thrown, then we're going to go in here. I need to decide where we are here. On forward drawing plane, or on front drawing plane, on front canvas. So on front canvas is equal to is not is thrown, or my position dot scale greater than is greater than 1, I think. Hold on though, but I also need to do this. So on front canvas equals to, hold on a second, is thrown and the scale is greater than 1. Nope. I need more logic here, I think. It really comes down to, I think, this. If is thrown, then on front canvas is equal to, and I think position scale is greater than 1. It's going to be some threshold here, but I'm not sure what that is. We don't really have a way of deciding which plane it's on based on its scale, but it's a roughly, that's kind of the idea. On front canvas is equal to that. Else on front canvas is equal to this. We'll try that as a refresh on that. So we're going to refresh. Front overlay and refresh the back overlay. And refresh in that world. We get a fireball. Oh, give me a fireball. Why am I not getting a fireball? What's going on? I got hand position. Hand position is working. Give me a fireball. There you go. Okay, that kind of was throw. Alright. Not bad. You see that, Rory? That wasn't bad. Hold on.
Let's get another one go. Right, there we go.
So part of the problem, though, it seems like it jumps behind my hand just as I do the throw. And that actually never got in front of my hand.
Yeah.
It kind of gets it way, it's this number right here, right? This really needs to be like a 0.0. Let's try 0.7.
I'm trying to figure out where 1 is, because it should be a representative between halfway between the furthest forward and the furthest backward that you calibrated at.
Yeah, let's see if I can find those on screen. That's over in Leap Calibrator. And it's between 0.6 and 1.5. That's the back scale and the front scale, these two numbers right here. Okay, that's the default if I don't recalibrate it. So basically calibrated it so it was working fairly well, put all the numbers in so it defaults to that. So we're basically talking about, halfway between those, but, because we're dealing with a wide angle lens, where is that point exactly? Where does it lie?
But doesn't the point change based on where your hand is in the Z order when the velocity hits throw speed? So you could start right at the back,
I think that's
and
a
you
good
could
point.
go fast, and it would be in front of you because 1 is inherently in front of you. But if you start in front of
I agree.
that midpoint and go fast,
All right, so let's figure that out. If it's thrown, I need to know the Z point of both the object and the hand. That's really what we need to do. So let's go look at that. I don't think hand 2D has that yet. I'm going to say it does not. So we're going to call that the Z point, something like that. If I can get my fingers on the keys. Z position. Like that. Position Z, finally. All right, I've got position Z. Let's close this down. And then I need also a position Z for the thrown object. Do we agree with that?
yeah, that sounds good.
Let's do that. Gotta go?
That's my gotta go.
All right, right. No, I appreciate
Complicated evening. Got to prepare for lockdown. England's going to lockdown again. We've got a month where basically as many things as can shut down. But we'll see.
All right, buddy. Jetson just arriving and
I'll still be with you tomorrow. That'll all be fine.
Right. Bye, Rory.
See you later, man. Bye bye.
Jetson's just the time to take Rory away. All right, so Jetson, we're working on throwing three-dimensional objects in space. It's not bad where we are so far. We're getting close. We need to figure out whether the flame is in front of the hand or behind it so we know where to draw it, what plane to draw it on. So if I throw it backwards, it goes behind my plane. It's drawn on the other side of my hand. If I throw it forwards, it's drawn on the front of my hand. So we need to know the position Z of the thrown object, and we need to know the position Z of the hand in two-dimensional space. I mean, in three-dimensional space, and see which one is greater than the other. So based on that, let's see when these are set here. Set column properties. So I'm going to say position Z here is equal to hand dot palm normal dot Z. Okay, good. That's step one. Step two is in world. When we update our, where is it? Update here. Virtual 3D object, we update its position. Is that where I want to be? Not quite. It is in thrown objects. I'm going to add this as a thrown object. Well, current position, we're going to come in here and say thrown object dot position Z is equal to current position dot Z. All right, good. So now we're going to have both of those in there. By the way, I really appreciate that, Rory, that suggestion you gave us on determining where the plane is. You're totally right. I'm so glad you said that. My head was not there, and I think it would take me a while to get there. We never got the Roy leaving party. That's true, sir. We never did. Only there were a way that you could invoke that remotely from the chat room. Okay, so now we got our position Z. Now I need to add these to the pieces we have here. No party. I didn't see the party coming in. it was called for, but it didn't happen. Well, that's not good. Here you go. Get out of here. All right, there's your party. Thrown object. Let's get over down into TypeScript. Thrown object. Where's my thrown object? There it is right there. We need a property of type number. And it's going to be called position Z, like that. So we've got that. And then in our hand 2D, we're going to also look for its position Z. Okay, now figure out which plane we're on that we want to draw on. If it is thrown, then on front canvas, we don't want to do this anymore. That was a crazy idea. Hand dot position Z. I think as I move forward, the numbers get bigger from the leap. So we want to say if the hand position is less than, meaning behind, so if it's forward, I'm sorry, hand position Z is greater than, where's my thrown object? Well, I think I'm going to change this to get thrown object. Get thrown object from index. And okay. All right, get thrown object from index. Kind of working through this. Oops, there's what I want right there. Sorry about that. So that's going to be my scaled point. I'm going to get my thrown object right there. And so now, if it's thrown, we know thrown object is going to be real, so then thrown object dot position Z. Okay, so on the front canvas, if the hand position is greater, nope. Wait, greater means moving this direction. Greater than the thrown object, then we got to be on the back canvas. So I think it's the other way around. If the hand position is less than the thrown object position. I think that's the answer to the question. Okay, let's run this. And let's refresh our overlays. All right. Oh, Sully did it just before you came in. Okay, so the party started and then Jetsam came right in. I got you what's happened. It's fun watching Father and Son dance to this on Saturday. Okay, cool. Yeah, on Saturday we got Kids Code. We're doing it on Fridays too for a while. So you can come in either of those days, beginner-friendly coding. All right, so now let's see if that's working. Let's grab a fireball. Wait, I gotta initialize. Turn it on, make it active. I'm checking that checkbox to make it active. Right there. Turn it on. There we go. Fireball. That was a little bit of a throw there. Yeah, it's a little quickly there. Throw it. So that's not bad. Throw it. Nice. Throw it. Nice. A little bit, kind of some weird stuff going on, but it's not bad. It's not bad here. Let's see if we can. Fireball. 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 I don't get any fireballs. Let me take off my strap. No fireball. Show live hand position. That's working. And if I get a fireball now, this is like the second time. Yeah, that's kind of interesting. Okay. Okay, not bad. The there's a little bit of a. That's good. I also like that even if it's across my face, it's not bad. There's a little bit of a trying to decide when the fireball is leaving my hand. It's not bad. Now I want to come back down. Wait, what's going on? Why is it not coming back down? Oh wait, I know why it wasn't working, because I didn't have this. This didn't have focus. This needs to have focus sometimes to get the hand data. Okay, so let's bring this over here. Fireball. All right, let's see here. Up. Okay, there's a jump that's happening. Burn all the flowers. There's a jump that's happening, and I know why the jump is happening. The jump's just on the throne. It's a little bit disruptive. The jump is happening because our get current position is based on our start position, and our start position is, I'm contending, is wrong. Throw vector dot position is wrong. Throw vector. Get throw vector. Get throw vector. Throwing point. This I contend is wrong. I think this is wrong. It's using the position, which is the palm position, is what I believe. Really? Okay. Coming from the Q. So this Q is passed in. throw vector. Add velocity, position. This is what I believe is the problem. Palm position. This is the problem. I don't want palm position. I want palm attach point is what I want. Which I don't have here. Let's go look at my palm attach point, how we're calculating the palm attach point. It's this, palm position plus palm normal times the palm width. So what I want to do is, we're going to call this get attach point is what we're going to call this. Let's close this down. The get attach point, like that. So we need to get attach point here, but we're also going to get this. So basically what this does, the palm normal points out from the hand, and it's a normalized vector, which means its length is 1, I believe. And the palm position is right there. It's right there in the center of the palm. So this get attach point basically says, let's pop out the width of the palm, so it turns the palm sideways and points it out about that far. So that's where the fireball is going to be. But when I throw it, it's using this position here. That's why it's got that jump right there. So, so I want to use get attach point in that other location we were at, which I think it's here. Let's see what's calling add velocity. Yeah, I think I want it here. Get attach point of hand. I think that'll fix it. So we won't see the jump. Let's try it. Running. Keep active. Get it off screen a little bit so we've got a nice dark background. Do fireball. Alright. Do a throw again. Throw. Throw again. Yeah, better. Throw. Doing different size fireballs here. There's a little bit of curve away from the camera, I'm sensing. Just as it comes in, it's kind of going like that. I think it's also because it's coming outside of the scale. I think that we might have to look at the math for that scale. But it's not too bad, right? That's interesting effect. Seems to wrap across to the left side of the screen as well. Yeah, we were seeing something like that that was really weird. Whoa! Yeah, I'm not sure what's going on here. But we need something to kind of detect, are we out of bounds, get rid of it. We need to take a look at that wrapping. I think the wrapping has to do with, I think it's a simple like one line of code bug somewhere. There you go. Up. Let's see if I can just throw it straight up. Up. And then come back down. Oh, that's cool. I almost got, if I added code to catch it, oh, it's really cool. Hey, baby. Let's try again. Yeah, I think I can add code to catch it. It's not bad. Yeah. It's not bad. It's getting closer. Not sure what was that, what that was. And there's a little bit of a triggering of the throw. The throw code I don't think is great yet. Sometimes I get a false trigger. There's small little problems with it, like if you notice the fire on the front, if I throw it and it gets bigger, that fire in the front stays in front instead of moving backwards. So there's no sorting on the Z plane in terms of what order do I draw the sprites in. And if we added that, it would look better. It's just a small little thing. I've noticed my mind is like, wait, what? Something's a little wrong. Right there. A little bit, you see it. You see a little bit of that issue. And then it stops. I'm not sure what's going on with it stopping. Got some serious fire. All right. I do like that in general, though. It is getting a sense if I'm throwing it up and it's, you know, going in the right direction, right? That part is very cool. The only thing that's, it's funny. So it's not perfect, right? But even with as rough as it is, right? Even with it as rough as it is, my brain is like doing this thing where it's like, wait, why can't you feel it in your hand? Do you know what I mean? I'm like, it's like I feel like I can push right through it, and it doesn't make any sense, right? Even though it's a little bit crude, I'm like, there's no heat. You know, my brain is like, why isn't it hot? My brain is like, why can't I feel it? So the fact that my brain is like confused by this, I'm going to call that's not bad, right? It's not bad. Yeah, and I do like this too, where I can, you know, without losing it right here, but I turn it around here. I can kind of go back, and, you know, it's behind us and in front of us. I think the triggering is a little too sensitive. Let's see what we can do about that. I'm going to do something else too. I want to come over here. I want to go to the page. I just feel like that one fireball, the orange fireball, is too big. Yeah, it's 260%. I'll make it 160% like that. Let's throw that here. Let's get that fireball. Oh, we need to get over here. The appears. All right. Yeah, so it's bigger. Yeah. It's not bad. It's really not bad. It's like with a little bit of tweaking, as long as we don't have, you know, bugs that are too bad here. Come on, guys. Give me, there you go. And also sound effects. That's cool too, right? Being able to put out the just by doing that. Yeah, it's not bad. Bro. And then a catch, or maybe not. Maybe throw to another player. I'm not sure what's happening here. So there's a couple issues. Maybe we should keep track of the issues here. You set the world ablaze, says Coding Gorilla. I'll just pick up another one. Yeah. There's a little bit of, we go off, we lose the tracking a little bit as we come back out here. Look at that. It says I move back, but I think that that's related to what actually happens with our position as we're moving back too. If I say show live positions, I move back, it starts getting kind of in the wrong place a little bit. So it's good there, but back here it's not so good. Also, look at the font change. As I come back here somewhere, the font changes there. That indicates there's an exception in the code, and it's using a different font. It's not able to set the font correctly. Is my take on that. That's cool. So that doesn't look so good right there, right? My thumb, it's there. And then I switch it there. I really want to switch it to the back plane here, I think. It feels like I'm switching it a little bit too soon. If I do it quickly, it's not that big of a deal. That doesn't look great. Cool. I am thinking that's probably going to be a show for today. Is what I think. Tomorrow morning, tomorrow when I start up, I'll probably work on the sound effects for it. And then when Roy joins us, we'll continue to clean up the throwing on this, maybe work on catching as well. That's probably what we'll do, work on catching the ball tomorrow. All right, so not bad for 4 hours of work. Yeah, I totally want to catch that thing now. Totally want to catch it. I'm not getting anything out. Yeah, and I want to tweak to get the throwing right as well, so the throwing feels a little bit better. Some of these are genuinely not bad. They're like, aside from some of the false positives we get, push, right? I just kind of push it out there. What's going on with that? I'm not sure. All right, we'll look at these tomorrow. We'll get a raid going right now. Thanks everybody for joining us. I'll leave you with that fireball floating up in space. I don't get it. We'll send you over to BBB, Triple B. Have a good day, everybody, and we'll see you tomorrow.